What's up, guys? It's your boy, Mr. Ernst, and today we're going to be talking about something that's called an arithmetic sequence. Ta-da! So let's start off with what is an arithmetic sequence, and why are they so cool? Why do we even care about learning about them? So, sequences are broken up into things called terms, and each one of these terms I'm going to label using the letter N. So we got N. So let's say we're going to have 1 term, 2 term, 3 term, 4 term. Red fish, blue fish, etc. In this, let's say my very first term, let's say we start off with the number 4, and from there we're going to add 2 to give us 6, 8, and 10. And you'll notice that between each of my terms here, as it jumps up, each one of these is adding the same amount. This is commonly referred to as the common difference, or the common change, or whatever you want to call it. Because we are adding to each time, it makes it arithmetic. We are adding the same amount every time, and it creates a sequence. And this we are going to label as this little section over here. We're going to label as A. Whoops. I'm going to label this as wrong color. A of N. So in other words, this works very much like a function where if I have A of, let's say, 2, so if I'm replacing my N with 2, my answer would be a 6. And A of 4 is equal to 10. Cool? Now, I know what you're thinking to yourself. If we have a constant change, plus 2, plus 2, plus 2, plus 2, Mr. Ernst, isn't this almost exactly like a linear function? Like, what difference does this make? This is linear. How is this different? Arithmetic sequences are different from linear equations, but they're also very, very similar. The easiest way that I can show you their differences is in their graphs. So let's look at linear graph versus an arithmetic graph. Arithmetic graph. And we'll come over here. I'm going to be fancy and grab my line tool. Oh, that's not nearly big enough. Let's try like this. Ho ho. There we go. Much better. And let's say for my linear graph, I have 4 points. I've got 1 point here, point here, point here, and point here. So basically, like I've got 4 points here, 1, 2, 3, 4, and I've got those 4 points there, right? I'm actually going to copy this graph and paste it over here so I can show you the exact difference between these two. So same exact graph happening over here. So when we have linear is all based off of, remember linears are y is equal to mx plus b, and it's because our slope, our m, this guy right here, our m value is a ratio. It is the change in y over the change in x, and because of that, it means that even if I was to, say, cut my x value in half, which would bring me down to about here-ish, it also cuts my y value in half, which means that this point is also a point that's a solution for linear. And if I cut it down by each of them by a quarter, it might come down here. There's a solution here. There's a solution here. Because this is a ratio, it means that we not only have these 1, 2, 3, 4 points, but it also means we have all of the points in between. That's the wonderful thing about this ratio, is that we have everything in between the points. Points and everything in between. This means we have something called continuous. I'm going to erase this now. Get this out of the way. We have something called continuous. Wait a second. US, right? Yeah, there you go. Data. It's continuous and infinite. Cool? Arithmetic data is different in that it does not include stuff in between. There are no points in between. There is no line that goes through it. Arithmetic is just these 4 points. If I told you that this was my sequence, 4, 6, 8, and 10, you would plot those 4 points, 4, 6, 8, 10, and be good. Finished. No more graphing needed. There's only 4 points. There's no points down here. There's no points up here. It is just 4 points. That's arithmetic. And this data is called discrete data. And the best way to describe the difference between these two types of data is that discrete data is something that is counted, while continuous data is something that is measured. To give you an example, a count. Every day when we have our classroom, I have to take attendance, and so I count the students. I might count 31 students for the day. I might count 34 students for the day. I might count only 29 students for the day. These are all part of my sequence. I would never count 29.5 students. I'm never going to have half of a student there. So it is not including everything in between. I can have 29, I can have 31, I can have 34, I can even have 0 students show up. Sad times for me. But I'm never going to have 33 and 3/10. It's never going to include fractions or partials. Anything you can count. I have 5 apples. I have, 32 megabytes of RAM or something. I don't know. Continuous data is something that's measured. So if you picture a ruler, you can measure something that's 1 inch long, 2 inch long, or 3 inches long, but you can also measure something that's in between them. You can measure something that is 2.5 inches long, or measure something that is 1.75 inches long, and so on and so forth. You can measure everything in between 1 and 2, and 2 and 3, and so on and so forth, which is why the data is continuous. So examples of continuous data would be things like measuring someone's height, or measuring someone's width, or if you really wanted to be rude, measuring someone's weight. So anything that you can measure is continuous data. Anything that can be counted is discrete data. Cool? With that in mind, we're going to rewind back to this original sequence, and we're going to talk about how you can write these. Equations. Go back to layer. Go back to do. I lost which layer. There we go. I lost which layer had it there. Okay. So looking back at my sequence here, let's look at how we can write different equations here. So looking at this, there's 2 ways of writing this. If I'm going to write these in terms of each other, a of n and n, when I'm writing this equation, I would write a of n is equal to, and there's a couple of specific terms we need to know. You have n, you have n plus 1, and you have n minus 1. Regular old n is what's called your current term. N plus 1 is your next term. And n minus 1 is your previous term. And since these are all in relation to n, all this means is, let's say I choose 3. This is my n. N plus 1 would be 4, my next term. My previous term would be n minus 1. The minus 1 and the plus 1 just tell you if it's the next term or the previous term. And that's really all you need to know about that. So for example, this pattern, let's say I'm going to write a of n, so a of my current term. My current term is equal to, I'm going to say my previous term, a of n minus 1, and then we know our pattern is to plus 2. I'm adding 2 every time. So showing you what this kind of looks like, let's say I choose to input n is 3. So let's say I'm going to say 3. So what is term 3 equal to? Replace this n with 3 as well. So I have, what is the value of term 3? What's the output? What's my term when I have term 3? So over here I have 3 minus 1. 3 minus 1 simplifies to 2. So I have term 2 plus 2. So term 2 is 6. This is going to turn into term 2 is 6. So I'm going to have 6 plus 2 is equal to a of 3. 6 plus 2 can simplify to give me 8, which means my third term is equal to 8. My third term is equal to 8. It checks out. So I want you to notice that when I'm writing this, this equation is in terms of n. My current term is equal to my previous term plus 2. Whatever my term is equal to my previous term, 6, plus 2 is equal to 8. Makes sense. My current term is 6. My previous term, 4, plus 2 is equal to 6. You can also write this in terms of the other direction. N plus 1. So my current term is equal to my next term, and instead of plus 2, it's going to be minus 2. So once again, if I was up here, my current term, let's say 3 is my current term, is equal to my next term, 10 minus 2. So 10 minus 2 gives me 8. Cool? When it asks you to write the term in something that's a little bit more generalized, how am I doing on time? Good. If it asks you to write the term in something that's a little bit more generalized, it basically wants you to write what's basically actually, you know what? I'm going to cover that in a separate video because that's pertaining to the actual question itself. But that's the general idea, is that sequences are kind of handy because you can write them in terms of next term or previous term. Cool? In other words, again, in this one, I'm saying current term is equal to my future term or my next term, subtracting by 2. And that's my constant change that's happening. Cool? And that is the basics of arithmetic sequences. In the next video, I'm going to start going over problem 1 with you guys so you guys kind of have an idea of what we're doing there. Cool? Yeah, see you there. Bye.